A 4-step mechanism is suggested for the reaction of hydrogen peroxide with iodide ions in acidic solution. And step 1 is the rate determining step. State what is meant by the RDS. So the RDS, the rate determining step, is the slowest step in a reaction mechanism. And the way to think about it is it sort of determines the overall rate of reaction. So the analogy is, imagine you are on a carriageway driving in a car, and in front of the cars there is a large lorry which is moving at a slow speed. So the way to think about this is it doesn't matter how quickly you move up to the back of that lorry or how slowly you drive behind it. Ultimately, the speed of that single lane of traffic is determined by the speed of the lorry at the front. So tailgating the lorry or hanging back makes no difference. You are going to go as fast as that lorry dictates. And it's the same idea with the rate determining step. So there may be multiple steps in a reaction mechanism, but ultimately the speed is determined by one step. Use this mechanism to construct a balance equation for this reaction. So I'm going to do the workings for this one here because that's a lot to do on a single line for 1 mark. In order to determine the overall equation, it will be the sum of all of the parts of the mechanism added together. So what you do, if I just strike this with a red line, you literally add everything on the left to everything on the right. Then you cancel out things that are common to the left and right, and that will leave you with the final equation. Let's go ahead and do that. So we've got on the left hand side H2O2 plus weakens, and cross them off as you go along so you can keep track of what you're doing, plus 2I minus plus 2H plus, because there's 1 there and there's 1 there, plus OH minus plus HIO, make that a bit more clearer, HIO plus IO minus. So that's everything on the left hand side done. Goes to what's on the right hand side. So I can see there's 2 water molecules, so 2H2O. I can see there is an I2, an OH, so that goes and that goes. I can see there's an IO minus, and then finally a HIO minus. So that's everything added on the left, everything added on the right. Now the final step is to cancel out things that are common to left and right, and only things that are common to left and right. So they must be identical in order to cancel out. So I can see we have a hydroxide there, so that's going to go with that one there. I can see there is a HIO on the left, which cancels with the one on the right there. I can also see there's an IO minus on the left there, which cancels with the IO minus there. And then an iodine. Yes, we've got I2 on the right, but we have iodide on the left, so that's different. H2O on the right, there isn't a H2O on the left. And then the H plus on the left, and there isn't a H plus on the right. So what does this leave me with? Now it's really important at this point to do a quick check to see if that is balanced. So I can see there's 4 hydrogens on the right, and there's 4 on the left, 2H plus, 2 and H2 there. I can see there's 2 iodines on the right, there's also 2 on the left. And lastly, with these ionic equations, it's really important to check that the charge is balanced as well. So the total charge on this side is 0. There's no charge on the right hand side. And the total charge on this side is also 0, because we have 2 times minus 1 there is minus 2, and then 2 times plus 1 is plus 2 there. So minus 2 plus 2 is 0. So my final equation will be H2O2 plus 2I minus plus 2H plus goes to 2H2O plus I2. Part 3. Deduce the order of reaction with respect to each of the following. So what I need to determine is the order with respect to the peroxide, to the iodide, and the H plus. Now how can I do this? So the way we can do this is by remembering a simple rule, which I'm going to write on the right hand side here. And the rule is this, and it's to do with the rate equation and the rate determining step. The order with respect to each reactant in the rate equation is equal to the number of that reactant in the rate determining step. So let's make an example up before we return to this final part of the question, just to make sure you've fully understood this. So let's just say we've got an equation where we've got A plus 2B produces C and D. And we've determined that the rate equation, so experimentally determined that the rate equation is rate equals K, A to the 1, B to the 1. So they're both order 1. That means that in the rate determining step, there will be one lot of A reacting with one lot of B, because the order with respect to A is 1 and the order with respect to B is 1. So that means one lot of A reacts with one lot of B to produce something, an intermediate X. Then in the second step, this is step 2, that intermediate X, whatever that is, reacts with whatever's left in the overall equation. Well, if you look at the overall equation, the only thing we've got left is 1B, because the first lot of B was used in this step. We got 2 of them, so the second one comes in the second step, and they then will react to produce the products C and D. So if I know information about the rate determining step, then I will know what reactants appear in the rate equation and their orders. So do we have this clue in the question? Well, yes, we do, because what it says there, step 1 is the rate determining step. So if I just remove the annotation now, we can see that in step 1, there is one lot of hydrogen peroxide and one lot of iodide. So immediately I can say the order with respect to H2O2 is 1. The order with respect to I minus is also 1. And the order with respect to H plus, well, H plus doesn't appear in the rate determining step. The fact that it's not in the rate determining step tells us that it's not in the rate equation. So therefore its order must be 0. So we have order 1 with respect to peroxide, order 1 with respect to iodide, and order 0 with respect to H plus. So in other words, the H plus doesn't affect the rate of reaction. So what we can deduce from this, that is probably going to be a large excess of this, so loads of acid catalysts to get this to work, so that it doesn't affect the overall rate of reaction. Okay, so the rate equation for this one would have order 1 with respect to H2O2, order 1 with respect to I minus, and therefore there will be one of each in the rate determining step. Thanks for watching, and see you in the next one.